Please welcome John Pasquarette, Vice President, Corporate Marketing and eBusiness.
Good morning. I'd also like to welcome you to NIDays today and look forward to a great day of technical sessions and collaboration between all of you and our NI experts here. I want to talk a little bit about graphical system design and give you a few examples to try to explain the real power of the platform we're building and putting in your hands. Now, just as a quick review, we all know what's powering our technology and our market as a whole. Moore's Law has driven the technology for the last 20 years to just incredible levels. Billions of transistors are now available in these chips, to the point where your mind can't even comprehend the complexity of the technology that you're using at your fingertips. And that's where higher level tools become required. In the software space, programming languages have evolved from very low level tools to high level system design tools. It's the only way you can really wrap your head around the challenges of designing these types of chips. So electronic system design type tools make it possible. In our world, we have a similar high-level abstraction to take advantage of the complexity, and that's Labview, a graphical language that we all have heard about and many of you are using today. The key with Labview is it takes this notion of high abstraction and applies it to the hardware. At times, Dr. T, our founder, will say, our goal is to make the hardware disappear. And what that means is, after all of our hardware engineers got very nervous, Labview makes all of the complexities of the different types of platforms for measurement and control go away. It gives you a common approach to get data from the real world and do something with it. And allows you to focus on the problem at hand as a design engineer, a test engineer, an expert in a certain area. You should focus on the problem and not on all the details of how to make everything work together. And that's what graphical system design and our platform allows you to do, is focus on that approach and apply it to many different applications. Now, another common misconception is that NI or Labview is a test platform. It is. We're very well known as a test and measurement supplier. But through graphical system design, you're seeing our capability spread into the entire process for developing products. So this is the common V diagram that shows the process for designing at a very high level, algorithms, and then ultimately implementing them in a system or a chip, and then testing from component up to full system testing. So this is a very common approach. And the opportunity here is to actually leverage tools and IP across this entire process. And through graphical system design, many of our customers now are doing that. So you're starting to see not just incredible test systems being developed through graphical system design, but also embedded systems that become part of the product that you're developing. And obviously, they're set up to be tested very quickly as well when you're sharing some of the same IP. So this approach is really bridging between design and test. One of the technologies that embodies the notion of graphical system design, probably better than any other, is FPGAs. And we are continuing to build FPGAs into our platform, and while we're doing it, trying to make it invisible to the end user. So through Labview, through higher level tools, and with integration with a variety of I/O, you now have the power of custom logic, custom hardware at your fingertips to build these types of systems. And we believe as well that this will unlock incredible potential going forward. Now, it's good to see, that as a vendor, we are very excited about this technology, and we see success in our customers every day. We also have some recent studies of the market where we've seen some data that tends to support this approach. It's pretty interesting. So talking to over 1,000 different users, we found that users applying graphical system design with Labview are able to get embedded system projects done in about half the time than the traditional approach. The other interesting thing is the average size of a team is also smaller. So we're finding that this approach is enabling smaller teams to do more and do it more quickly. And we're very excited about this. Obviously, as we look at growing areas and growing markets and a big focus on small and medium enterprises here in India, we feel like this is a match made in heaven, and we're very excited about what's possible here. So I want to spend a few minutes finishing up talking about a few applications in detail in some very exciting areas. RF and communications and life sciences, and then later we'll look at something in the energy space. And all of these are being implemented using FPGA technology and graphical system design. So when it comes to wireless communications, the protocols just continue to get higher performance, but also much more complicated. And in this case, looking at 802.11, you can see just in a very short time how much more complicated it is to develop and take advantage of this technology. One of our customers is Qualcomm Atheros, and they build receivers, WLAN receivers for 802.11 AC. And this is a block diagram of the chip that they design. And even looking at this chip, you can see there are multiple stages where you can apply different gain settings. So this one chip has literally hundreds of thousands of modes that you can put it in to operate. And so with all of this additional complexity and configuration, the funny thing happened, the products keep getting cheaper and they have less time to test them. So the complexity is going up, costs are going down, and as the test engineer, your time is getting shorter. So it's very challenging. Now they've developed test systems for many years, obviously, over the evolution of these products. And you can see, starting in the early 2000s, their focus was on traditional rack and stack equipment. And in 2007, they applied PXI modular-based approaches and received 10x the performance. So they were able to test 10 times faster just going to a modular approach. Just this year, we have some exciting new technologies based on FPGAs that we'll be highlighting later today. I can't tell you too many details yet. But they have been an early user of this technology, and they've been able to achieve 200 times faster the performance in making these measurements. And again, it's based on FPGA and graphical system design. Now this is an exciting number to look at when you consider the sheer speed at which they can make the measurements. But it goes a lot deeper than that. It's a much bigger difference than just faster testing. Because there are so many different modes for setting up this product, they have to choose in their test algorithms which modes they're going to actually test. And so in previous generations of their test systems, you can see they get a sweep across a variety of settings to try to get an understanding of is this particular chip performing as it needs to. Using this latest technology, they're able to get a much greater characterization of the product across the entire operating range. And so they have more insight into their designs than they've ever had before. So not only are they testing faster from a characterization standpoint, they really, for the first time, fully understand what this design can do. And that's where you start to see the leverage between the design process and the testing really coming together. But in the end, that's a kind of a classic test challenge, whether it be in characterization or production. How do you get more data and make more tests in a shorter amount of time? The next example I want to highlight is from life science, where it's really indicative of an embedded system getting something to market faster to make our lives better. This example is from a company called Optomedica, and they work in the vision area in terms of your eyes, not our vision technology, but obviously they use that too. And the problem they're trying to solve is cataracts. So all of us, as we get older, have to start to use reading glasses because you can't see things up close. They're trying to put reading glasses out of business. And so they have so to take a look at the problem, a cataract is the hardening of your lens in your eye. So you see, this is how it's supposed to work. As you get older and it hardens, the light reflection doesn't work correctly, and you get a blurred image on your retina. The solution to that is to take the lens out and put in an artificial lens to properly refract the light so you can see again. It sounds easy, but the way that it's actually done is through a procedure. And this is, luckily it's an animation. We have a real video of this, but the doctor actually uses a scalpel to pierce the eyeball and then try to peel off a circular lens, circular shaped opening. And then from there, you can see that there's a lot of variation. Sometimes they do a good job, sometimes it's not quite circular, because this is literally being done by a human. Once you get the opening, then you use the scalpel to basically break up the lens in the eyeball and suck it out. And then a new one is kind of shot back onto the eye and it opens up, and now you have a new lens. Now you can imagine this procedure can be pretty painful. And there is an opportunity for human error. You can see the resulting lens may or may not be perfectly placed. And so Optomedica saw this as an opportunity to build a machine to automate this process. It's a complete closed-loop control embedded system that will automate that entire process. And you can see some of the technology. It's using image processing and optical coherence tomography to create a perfect 3D image of the inside of the eyeball. And it outlines areas that the lasers can and cannot touch. And then it uses high-powered lasers controlled by high-speed DACs to actually perform the procedure. And so the basic idea is now, rather than using a scalpel to go in and cut and break up the lens, it's actually using a laser to ionize or vaporize the lens. And here's a real image of it. And you can see the lens is being vaporized, basically. It's all done with a high-power laser, very precise control. Now, this has been developed by a small team. Obviously, they're doctors in ophthalmology. And it's a machine that is in action today. You can walk in, get hooked up, and you're ready to go. In a matter of seconds, the procedure takes place. And it has obviously much better performance than a human trying to do the same thing. So you can see on the left some examples done by doctors who are very good, but there's a lot of variation. And on the right, perfect ovals in place and the procedure all done very quickly. So how do you measure the impact of this? Obviously, they're a small team. They were able to get it to market in a matter of months, and it's successfully operating. But at the customer level, the first customer had a vision of 2400. And after the procedure, their vision was 2015. And so they're bringing a better vision than they've ever had in their lives based on this technology and this machine. And again, it's all based on FPGAs and graphical system design to make this possible. So to wrap up, I wanted to share a little bit of what we're doing to make this possible for all of you. The world is becoming very small. I had to remind myself of that yesterday when it took me 28 hours to fly here from Austin. So it's big when you're trying to go around it. But in terms of science and engineering, we are all now collaborating and sharing ideas similar to the events we're having today, but we're doing it on the web. So it's now the age of the user. You in the audience have an incredible amount of information and power at your fingertips. Whether you're looking to buy a new car or trying to figure out how to design that next system, the first place you go is the web, and you can read what other people think, you can get reviews. It's an incredibly powerful piece of information that now you can start with. And we at NI are very aware of this, and we realize for years our products really don't do anything on their own. They're all brought to life by the developer community. And that's why we have these events. But we've also built capabilities on our website to allow you to share and collaborate. And we have an exciting new announcement that Bhupinda is going to help me with for India specifically. So I understand we have something new. What are you here to tell us about?
Good morning, everyone. Okay, so moving ahead, let's have a quick walkthrough of the experience that Labview enabled the NI India community has to offer us. Labview enabled the NI India community. It's a single network for students, for academicians, for researchers to come together, collaborate, and to create discussions, to share and exchange technical resources, as well as create them, and to come together and collaborate on different applications. So essentially, this would serve not only India, but globally for users to come together and start discussing on applications they are working on. Putting it simply, it's simply a social network for engineers, for students, and researchers. So now, while we've discussed all of this, and we know that out of the several features that Labview enabled, the community would equip us with, let's see some of them right here. So starting with creating discussions, as I've mentioned that the users can go online, log onto the community, and start sharing their ideas, their approaches. And of course, they have a vast knowledge base of some 800,000 discussions that are already live on the NI global community. Coming next, they can obviously collaborate on applications. They can start their own groups, which are revolving around the applications that they're working on, and of course, start sharing their ideas and get their applications run faster. Of course, they can build their competencies and check their competencies with the peers as well through the exciting contests and design quizzes that we're running on Labview. Now coming to codes and resource exchange. Now this, I think, is the most exciting features. On NI Global Community, we have some 100,000 codes already available, which have been created by users and the NI Developer Zone community. So they can get on to that and submit their own code and look out for a code or a resource that they've been looking for.
Is the community live? Is there something we can see today?
Of course, John. Let's have a look. So here we are, John. So we are at the landing page for Labview enabled, the NI India community. So as a quick glimpse, what we see is the community is divided into different sections like Planet NI, academics, events and webcasts, training and careers. So each of these sections essentially would be a repository for relevant resources under these sections. For example, Planet NI would serve as a networking point for different SMEs across India. We've just talked about how India is a budding seat for SMEs. For academics, I think this turns out to be the most active section on the community. Students and academicians can get onto this, start sharing their courseware, start sharing their projects, events and webcasts. It gives you information about the ongoing National Instrument local events, and of course, anyone can share their events, the relevant events. Training and careers. People can get onto, the users can log on to this section and look out for Labview jobs, probably crowdsource their projects to a budding set of Labview developers, and network and obviously connect with the Indian Labview Developers League. So, well, let's have a look at what's going on in the community right now. We have a set of popular discussions which revolve around, I see a job discussion right here. We have some popular documents. Let's check one of them. So here we are. This seems like a student project. The student has worked on mind control robots. So what I want to highlight is the amount of information that you can share on the community, the features that you can use, creating a document, you can start a discussion, write a blog post. So as we move ahead, we can see that the user has very well described his application, has very well described his hardware, has also included his VIs, his outputs, and it keeps on going. And we have the front panel as well. Now let's get on the comment section. Now this is where the interaction is happening. So we see people are overwhelmed by the application, and of course there are some suggestions coming in. They are discussing how it can be scaled further. So essentially this is one of the many features that we can go on and do on Labview enabled. To experience it further, we have a Labview enabled zone right outside this hall. You can go on, create your user profile, start accessing the features. We also have a set of exciting activities lined up for the day. You can go on to the community, share your experience with NI technologies, with Labview, at NIDays as well, and we have some exciting giveaways to give. So that's about it, everyone. John, I'll give it back to you.
Okay, just to close now, the interesting thing about the Labview enabled community is it is integrated completely in NI.com. So you take advantage of the more than 1 million downloads a year of example code and drivers, but we've matched it with a portal specific for India so that you can also share ideas and cross over from just web information to the users and the events, the user group meetings, and so on that are happening right here in India. So we're very excited to make this platform available, and as we mentioned, there's more information in the lobby where you can officially sign up and be a part of the community. Because again, the power of the platform is really sitting in the seats here with your knowledge and capability with graphical system design. Thank you.